diagram which shows the uniform bar supported under midpoint. Okay, LCD calibration. So it is a uniform bar of 1 meter, but the calibration is done from the midpoint. So 0 say it is increasing towards right as well as towards left. So this is easy to calculate the couple arm or moment arm. They have 1, 2, 3, 4, 5. 1. So this is 0, 10, 20, 30, 40, 50. Okay, this is 10, 20, 30, 40, 50. So the weight is kept at 40. So this is 40 grams. So weight of 40 gram force is placed at a distance of, at what distance it is placed? From the midpoint 40 centimeter, right? On the left. How can you balance the bar with a weight of 80 gram force? That is the question. So obviously you have to keep the 80 gram force on this side, right? And since the weight is double of this, then logically the distance should be half of this. So ideally you should keep 80 gram force at 20, but you don't know. Let's say you're keeping it at X. Right? We don't know where we are going to keep. So we have to calculate it mathematically. So balance the rod. Because what is 40 gram force doing? It is applying anti-clockwise moment. So obviously 80 gram force has to apply clockwise moment. How? So that both are equal. So how do we calculate the distance? So therefore, to balance the rod, anti-clockwise moment must be equal to clockwise moment. Anti-clockwise moment कितना है? 40 centimeter into 40 gram force. This must be equal to X into 80 gram. So therefore, X is equal to right. So we have 20. Therefore, X is equal to 20 centimeter. Okay. So 80 gram force has to be kept towards the right of the midpoint at 20 centimeter. This answer. Okay. So don't draw this, otherwise they might put it wrong. So after calculation, then you can. So no need to draw the diagram. You just do the calculation. This I have drawn just to show you. Okay. If at all you're drawing, you have to draw it at 20. Which is logical. If 40 is at 40 gram force is at 40, so 80 must be at 20 to produce the same moment in the other direction. Right? Now, next question. This beneficial question is, can we keep the bags out of the passage? Keep it this side. Keep it behind. There are no valuable features. Have you seen questions in your textbooks? Are they similar? Similar. You are able to do this, right? So this is the idea, because I think you're carrying books from different publications. So let's have a common source. Since the logic and the knowledge is same, you can apply that to solve your book questions. And if you're getting stuck in solving your book question, that you can ask me for help. So how many of you have tried sincerely solving your book question? Please raise your hands. Nobody. So how do you know that the questions are similar? You have tried? You've seen it. So please do try, because you will not know otherwise whether you are able to solve them or not. Okay, please do try. Okay, question number 6. Shall we discuss question 6 from YouTube only? Methods are similar. You've seen the questions, right? All right. So what is this question? A uniform meter rule of weight 10 gram force is pivoted at its 0 mark. What is it saying? The scale is pivoted at its 0 mark. That means right at the beginning. So it's a uniform meter school. Uniform meter rule. Meter rule will have a 0 mark and a 100 centimeter mark. And the midpoint will be at 50. These are the markings. And where is it pivoted? Here. So it says the weight of the rule is 10 gram force. So where should the weight of the rule act? Midpoint, because the weight will act at the center of gravity. And for a rod or a meter rule, it will be at the midpoint. Correct? So you have to just understand that the weight of the scale will act at 50 centimeter mark. Okay. So what moment of force depresses the rule? So obviously, this is the moment of force which will depress. The first part is, so it is pivoted at the beginning of the rule. The weight of the scale itself will apply moment of force. So what is the moment of force? This will be moment of force that depresses the rule is equal to, so it is 50 centimeter times 10 gram force. How much is this? 500 gram per centimeter. What is the direction? Clockwise, right? Clockwise. This moment is depressing the rule. And what is the second part of the question? So this scale will no more be horizontal, it will be tilted. Okay. What is the second part of the question? How can it be made horizontal by applying the least force? Okay. How can the rod be made horizontal by applying the least force? Obviously, to make the rod horizontal, you have to apply a anti-clockwise movement. You have to apply the force in the upward direction. But at what point will the force be applied so that the force is least? At the maximum distance away from the pupil, which is 100. Got it? That's a logical question. So the least force must be applied at maximum distance is from the pivot. The upward direction. Therefore, so here the force has to be applied at 100 centimeter. Will produce clockwise for moment of force. How much will be the moment of force? Balance your rod. Must be equal to 500 ground force. Right? Because this is the clockwise moment, and this is the anti-clockwise moment with least force. And you have to calculate what is the least force. Okay? Because the clockwise moment of 500 GF now should be produced by the least force. So what is the force now? Therefore, F is equal to ground force centimeter. F is 5 gram force in upward direction. That's it. That here, F is equal to 500 gram force for at 100 kg. Try the next question. Will we discuss the next question? So what is given here? This given here is a we have a meter rule. Okay, where is it balanced? It is balanced at 40 centimeter mark. Okay, so this is 40 centimeter. This is 50. This has to be 100. And this is 0. Can a meter rule be balanced like this when it is just a meter rule? No. Where will it be balanced? Should be at 50. So now in the question it says it is balanced at 40. So obviously this 50 will produce clockwise moment. So there has to be some weight kept here, right? So what is the weight? Suspending an unknown mass m at mark 20 centimeter. So you have at 20 centimeter, okay, some mass is suspended here, m ground force. Okay, that is suspended here, and this is at 20. Okay, something is suspended here. So the weight generated by mass is m ground force. Okay. And what is the weight of the scale? Mass of the scale is 100 gram. So this is 100 gram force. Right? This is 100 gram force. This is how it is balanced. So you have to find the value of m. At equilibrium. The weight of the scale will produce clockwise moment and suspended mass will produce anti-clockwise moment. This is theta. At equilibrium, m into 20 centimeter is equal to what is 40 minus 20? So this is 20 centimeters. And this is 10. This will be 100 gram force into 10 centimeters. So therefore n is equal to divided by 20. This is 50 gram force. So 50 gram force is the weight produced by m. So what is mass? 50 gram. Correct? Therefore, mass is weight. Is that correct? Okay. When you calculate like this, you will be getting the weight produced by the mass. So answer में तुमको mass पूछा है. Mass has to be 50 gram, not 50 gram force. ठीक है? 50 gram mass produces a weight of 50 gram force. Okay. So you may write instead of M, you can write W here. So that M will be 50 gram. Is that clear? Huh? Weight of M is 50 gram. In the second part, to which side the rule will tilt if the mass is moved to 10 centimeter? So where is 10 centimeter? Will be here. Now if the mass is moved to 10 centimeter, which side the scale will tilt? Clockwise or anti-clockwise? Anti-clockwise. Because this moment will now increase. Okay. So then what is the question? To which side the rule will tilt if the mass m is moved to mark 10 centimeter? Now what is the moment of force? At 10 centimeter, the rule will is 50 gram force. At 10 centimeter, what is the moment on 30? 20 plus 10. So it becomes 30 centimeter. What is it? Another forward will tilt. Anti-clockwise. Why it will tilt anti-clockwise? Because what is the clockwise moment? It is 100 into 10, 1000. Since it is greater than clockwise moment by 500 gram force. Gram force cycle. Okay? So it will tilt anti-clockwise since it is less than kind of clockwise moment. It of how much is that? 10 gram force. Okay. So the clockwise movement is 1000 gram per centimeter. That's why it will tilt towards, it will tilt anti-clockwise because it is more. Third figure, what is the resultant moment now? How can it be balanced by another mass of 50 grams? So now in the third part, resultant moment is which moment is greater? Anti-clockwise, which is 1500 minus resultant moment is 500 grams per centimeter. What is the direction? Anti-clockwise, because it is positive. Okay, this is the resultant moment now. When the mass was shifted to 10 centimeter towards left. So, in the second part to the third question, how can it be balanced by another mass of 50 gram? So, another mass of 50 gram, where will you keep? Where should you keep? 50 gram into 10, 60. 50 gram into 10 makes 500 gram. That is the difference, no? So, on the other side, that is at 50 only. You have to keep the 50 gram weight over here only at the midpoint. Isn't it? So 50 gram at 50 centimeters. Okay. Therefore, 50 gram force, since 50 gram force into 10 centimeter is equal to 500 gram per centimeter. 500 gram per centimeter. Clockwise में अगर हमको इतना करना है, तो it has to kept at 10 centimeters. Okay? So 50 gram force into 10 centimeter is equal to this. Therefore, 50 gram force, 50 gram force. Therefore, the mass of 50 gram has to be kept at 50 centimeters. Balance the because 500 gram force anti-clockwise resultant moment has to be balanced by 50 gram force centimeter clockwise. So clockwise on the right side of the pivot, we require 10 centimeter. So 10 centimeter comes at 50 centimeter mark. Is it clear? Read the question and then see the solution. Then it will make sense. See what is asked in the question. Because when the mass suspended on the left side is moved 10 centimeter towards left, the net moment becomes 500 gram per centimeter anti-clockwise. Okay. To make the rod horizontal, you have to suspend 50 gram to the right of the pivot at 10 centimeter. 50 to 10 makes 500 grams. Now that has to block. second part of third of. Completed the task of numericals, which is only 7 questions. And there are so many different types of questions given in the volume. So if you turn some pages back, so you have solved exercises, then you have, before that you have previous year board questions, right? Shall we try some previous year board questions? Shall we try some previous year board questions? Or shall I start the last part of this chapter with this? Uniform circular question. Huh? Board questions? Okay, let's do some board questions. I'll start using them in the next class. Okay, so come to page number 8. But from this year, the paper pattern has changed. You all are aware, right? From this year, more and more application-based questions. So, although these are previous year board, so the level will be at the board level. So, let's do it. But this year onward, the pattern has changed. Like 25 exam onwards. Okay. So now, this is on page number 8. What is the question? Door lock is opened by turning the lever of length 0.2 meter. So what is given to you? The length of the lever means OA, the perpendicular distance. Length of the lever is OA. If the moment of force produced is 1 Newton meter, then the minimum force required is, so since torque is equal to, you can say the length times
5 Newton.
Okay. So therefore, what is the length? 0.2 meter into F. The torque is 1 Newton meter. F is equal to so this is 5 Newton meter. Right? You said 5 Newton meter? Rihan?
Yes, sir.
5 Newton meter. Everybody got it? So the answer is given to the right. Option A. Okay. That is option A. Second question. So this is a fill in the blank type of a question. But the stone is tied to a string, it is rotated in a, so this question will skip because this is from museum. We'll skip this, okay? Because this is from the last part of the chapter which we haven't covered yet. All right. Now the third question. Question 2, skip till we do UCSE. Force, correct. Good observation. So force has to be Newton, not Newton meter, correct? Good observation. It's not torque, it is force. Then question number 3. So look here, it is Newton meter by meter, okay? Has to be Newton. So except her, nobody observed it. This kind of silly mistake has to be avoided. Okay, question number 3. A non-uniform beam. Now this is a non-uniform. So for all the question, you have been doing uniform meter rule. So what is the meaning of uniform meter rule? The thickness is same throughout the length. But now in this question, you have a non-uniform beam, like it is thick somewhere, and along the length, it is becoming thinner. So length is not thickness is no more uniform. Like this pen is uniform thickness, but in this example, the thickness is not uniform. So you have a meter rule, whether meter rule or any object like this. So it is a meter rule only, because you can see that the CG given is at the CG, the weight is 120 Newton. And this is, so where is it pivoted? It is pivoted at O. Calculate the value of F to keep the beam in equilibrium. Where is F? F is here. So now look here. Look here. This is pivoted at O. Where is the weight acting? At CG. The weight of the beam is acting at CG. So what is the moment? Like this. So how you have to apply the force? You have to apply the force upward. In the diagram itself, the force is given, right? So it has to produce anti-clockwise moment, ACW. This is producing clockwise moment. Okay. So what you have to calculate? You have to calculate the value of F to keep the beam in equilibrium, and the distances are given. So this distance is 0.2 meter, and this distance given is 0.8 meter. So simply apply. What will you apply? Principle of moments. So anti-clockwise moment should be equal to clockwise moment, right? And calculate F. So what it will be? It should be, so by principle of moments, by principle of moments, at equilibrium, where in the diagram itself everything is given to you. At equilibrium, what will happen? F into 0.8 meters will be equal to 120 Newton into 0.2 meters. Is it correct? All data captured correctly? Okay. What is F? What is it? This is in this question. Okay. See, I have taken the length till here. Okay, correct. So you have to take it. Is the arrow complete? Okay. Let's calculate and check. Yes. So then what it will be? What it will be then? 0.6. It will be 0.6. Will it be 0.6? Will it be 0.6? No. It has to be from the pivot. The distance has to be from the pivot. It is pivoted at one end. Correct. So where is it? Where is it supported? At the pivot. So the force, the moment of force will be from here. So it is calculation is same, right? But the interpretation was different. Okay. So by mistake the calculation is correct, but now it is correct. Okay, because you cannot show this calculation with this kind of a diagram. Okay, so now the diagram was incorrect, but this is correct. So this is 120. So this is 2 and 4 by 4 newtons, which is 30. So force has to be 30 Newton upwards. Right? So in some question answer is not given, but hope you got. Everyone got it? What we have done? So what is important in calculating moment of force is the pivot. Okay, so the moment arm is from the pivot. That is to be very well understood. Okay. Otherwise, chance of mistake. The fourth is a theory question. It says define center of gravity. Question 4. Anybody define center of gravity? Is mass and weight same? What is the difference? Mass is mass and weight is weight. What's the difference? Yes. Mass is the measure of composition of matter in a substance. Whereas weight is force due to Earth's gravity on that substance because of its mass. Okay? So mass and weight are two different physical quantities. Mass is measured in kilogram. Weight is measured in Newton. Weight is a force. Mass is a mass. Okay. Is it clear? So very common confusion. Mass is not weight. Whenever in confusion, compare it with the unit. Unit of mass is kg. Unit of weight is Newton. Weight is a force on that mass by Earth. What is weight? Force by Earth on that mass. Mass is measure of composition of matter in the substance. Okay, very different. So, what is center of gravity? What is center of gravity of any substance? Like in this case, what is center of gravity? अभी तो बताओ. Yes. What is center of gravity? Define center of gravity.
Center of gravity is the point where the weight of a body is assumed to be constant.
Correct. You have to say weight, not mass. So, is there any physical quantity where we assume the mass to be concentrated? What is it called? Center of mass. So, center of mass as a concept you know in 11th standard. Brief, they might have mentioned, but you won't be using it. So there is also center of mass. Okay. And for all symmetric bodies, the center of mass and center of gravity coincide. Okay, for all symmetric bodies. Okay. Yes, unless the gravity varies. So for a very large body like a mountain range, okay, so the weight is spread out at a very large geography. So that's when the center of gravity and the center of mass will not coincide. All right. Now, part B of question 4. A hollow ice cream cone has a height 6 centimeter. Okay. What is it? A hollow ice cream cone has a height 6 centimeter. Where is the position of its center of gravity from the base, broad base? Where is the center of gravity for a hollow cone? From base? Yes. 1/1/3 of the height. So height is 6 by 3 is 2 centimeter from the base. And how much from the apex? Sometimes the question is asked from the apex. So 4 centimeter. Okay? So we read the question properly. So this is from the broad base. Will its position change when it is filled completely with honey? Okay? Yes. Which side will it go? It will go towards the base. Okay? H/4 पे चला जाएगा. ठीक है? Or maybe not, क्योंकि cone का material is different, honey is different, so it will be relative mass, जो भी है, but it will go towards the base. Okay. All right. So try questions yourself. Year 2023. Keep trying, and if you have any questions, you can ask. Only 5 more minutes remaining, so you can try yourself. Try questions from year 2023. I won't be discussing all the questions. Okay? Some are enough. What should be the answer to question 5? Raise your hand. Okay, let me choose who will answer. You will answer question 5. Sit down. Clockwise movement produced by force about a fulcrum is considered to be negative. Everybody in agreement? Answer to question 5 is negative. Question 6, part A. You answer. Question 6, part A. No, in front of you. You. Yes. What is the position of center of gravity of a triangular lamina? What is triangular lamina?
And a flat sheet of paper, right?
Plane triangle. Okay, it is a plane triangle. Center of the triangle. Intersection of medians. Intersection of medians. What is the median? Vertex to midpoint of the other side. So it is the intersection of medians. Okay. Okay, when this triangular lamina is suspended freely from any one vertex, what is the moment of force produced by its own weight? In its rest position. What is the moment of force produced by its own weight in its rest position? Yes, now somebody raised the hand. Read the question again. Who would like to take a go at it? Where is the CG of a suspended body? Huh? Suspended body. Where is the CG of the suspended body? Below the point of suspension. Correct? CG of any suspended body is below the point of suspension. Okay? So weight is acting at CG only. So pivot and weight are in the same line. Is there any perpendicular distance? Line of action of force is passing through the perpendicular through the pivot. Is there any perpendicular distance? Huh? See, when I suspend this, let's say I hang it across the nail. Then what will happen? This CG, so this will tilt slightly. Okay? So the triangle will become like this. So the CG will come here. Right now, when you suspend it, it will tilt and this point of CG will come here now. You get it? So this is the pivot and this is the line of action of force. Is there any perpendicular distance? Right now there is a perpendicular distance. This is the line of action of force. But that will tilt it. And now when it is suspended, the CG is here no. So this perpendicular distance will disappear. You understood or no? Let's say this is the hook. Okay, where is the CG? At the intersection of diagonal. Now I am right now, अगर ऐसे है, where is the CG here? Now at the point of suspension, where is the CG? Right now it is here. When I suspend it, कहाँ पे आया CG? It is below the point of suspension. Is it turning now? So what is the moment of force right now? Zero. Because if the moment of force is acting, then it will keep on turning. Is it turning now when it is suspended? So what should be the answer to the question? Zero. ठीक है? Because अगर CG यहाँ पे तो weight यहाँ लग रहा है, तो उसके वजह से तो ये turn हो रहा है. During freely suspended position, it is no more turn. Zero. Okay. All right. Good.